CIDR stands for Classless Interdomain Routing. This is different than classful IP addressing. Classless interdomain routing throws out the classful break between IP addresses and uses them in a more efficient way, alleviating the load on the internet routers by allowing aggregation of your IP addresses, grouping them together. It also preserves IP addresses. We will use multiple Class C addresses in our example when we need more than the standard 254 hosts allotted to you by a Class C IP address, rather than using up a more valuable B or A address. CIDR borrows from the network bits and masks them as host bits. You may recall that the default subnet mask for Class C is 255.255.255.0. Well, we're going to change that. This will allow for summarization of IP addresses into fewer routing table entries, as I said, and preserve IP addresses at the same time. What you need to do first is figure out how many hosts your company needs. Then you take the number of hosts you need and you divide it by 254. This will give you the number of Class C addresses you need. The number you come up with must equal at least the number of hosts required. In our example, a company needed 4,000 hosts. When we divided by 254, we came up with 16. That gave us 4,064 hosts, but remember we needed at least 4,000. And remember that one Class C alone would allow only up to 254 hosts. So we're going to take 16 Class C addresses. Next, we need to determine this new subnet mask, which is going to allow us to do this. The subnet mask necessary to supernet these Class C addresses. We do that by determining the power of 2 that will achieve the needed number of hosts. So what to the power of 2 will equal at least 4,000 hosts? Play around, trial and error, plug those numbers in. We come up with 12. 2 to the power of 12 equals 4,094. Therefore, 12 bits are needed for the host ID, leaving 4 bits remaining for the network ID. We are going to borrow 4 bits from that third network octet. All right, so if you look below at the graphic, you've got 255, 255, 240.0. Where did that come from? That's our new subnet mask. That's the subnet mask needed in order to supernet this block of IP addresses. The 255 is the 8 bits, 8 ones. The next group has 8 ones. The next group, the third network octet, only has 4 ones, because remember we borrowed 4 network bits. So I made them 4 zeros, but throwing them over to the host side. You figure out then the decimal value of those binary bits that remain. And if you recall from your binary to decimal conversions, the far left one in that third octet is equal to 128. Moving to the right, you've got 64 plus 32 plus 16. You've got 240 bits left for your network ID in that third network octet because you took 4 bits away. So your new subnet mask for supernetting is 255.240.0. That's a subnet mask you will use for a range of Class C addresses, 16 of them.